All right, so we just finished example 2 in your section 8.5 notes. And so now we need to talk about a mid-segment of a trapezoid. A mid-segment of a trapezoid is a segment that connects the midpoints of the legs of a trapezoid. So you kind of can think of a mid-segment, it's kind of like the midpoint of a segment. When we did midpoint, it's the point that cuts the segment in half. Mid-segment of a trapezoid is the segment that touches the two midpoints of the legs. So the mid-segment cuts each of the legs in half. Now notice that these are different measurements, so a mid-segment can happen whether it's a trapezoid that's not isosceles or an isosceles trapezoid. So it works no matter what. So you'll notice that when you draw in the mid-segment of a trapezoid, it's also going to be parallel to the bases. And so when that happens, then we can use information like that to find segment lengths in a trapezoid. Again, you can pause whenever you need to if I'm going too fast for you. Okay, so now to find the mid-segment length of a trapezoid, you average the two base lengths. Okay, remember the average is when you add it up and there's two bases, so you're going to divide by 2. So for instance, if I was putting numbers, let's say this base is 10 and this base is 22 units, whatever that is. If I wanted to find the mid-segment, I would do 10 plus 22 and cut it in half to find the length of that mid-segment. That's what I mean by averaging the two bases. So I add the two bases and cut it in half, and so that's going to be 32 divided by 2, so then that means that that's 16. Well, that makes sense because average means it's directly between the two. So the difference from here to here is 6. So if I add 6, I get to 16, and if I add 6 more, I get to 22. Or if I went backwards, 22 minus 6 is 16, 16 minus 6 is 10. So that distance between the two of them is going to be the same. So basically you're trying to get that whole length and then cut it in half so you can get that mid-segment. That's always going to happen, that these will be the same distance away from each other on the number line. All right, so go ahead and paste example 3 in. Only example 3. Do not paste example 4 yet. Example 4 is going to be in our second and last main idea. So example 3, go ahead and pause and paste it in. Okay, so example 3, we've got 2 parts here. So notice by the markings, if they don't tell you that it's HK is the mid-segment, then if they show you these markings that H is the midpoint of this side and K is the midpoint of this side, so that's what the slashes are on each side, then you know this is the mid-segment. And so they want us to find that mid-segment HK. Well, remember how we find the mid-segment, we just went through a quick example, is you're going to average the bases. So I'm going to do 6 plus 18, this is part A, and cut it in half. So what is that, 24 divided by 2, which is 12. So HK equals 12, which makes sense. From 6 to 12 is 6 units, and from 12 to 18 is 6 units. So you're basically finding what's that mid-segment length there. So you add them and divide by 2. Add the bases and divide by 2, I should say. Okay? All right, now part B, notice they didn't put the slashes like they did on this other one, but they told us in the given information down here that segment NP is the mid-segment of JKLM. So this trapezoid here, JKLM. All right, and I want to find this X value and I want to find this Y value. Well, let's find the X first. Now this time they gave us the mid-segment and they gave us one of the bases. And notice this base is longer than this base. So this number down here is going to be bigger than this base up here. Well, the easy way is just to figure out what's the difference between here. If I did 12 minus 9, what is that? That difference is 3. Okay? Now I'm going from top to bottom here, you're going smallest, next biggest, and this will be your biggest. And you know the difference has to be the same. So 12 plus 3 is 15. So that means X is 15. Now, another way that you could have done it, if you wanted to do the math, I could have set up a mini equation here. I could do this base plus this base. 9 plus x divided by 2 has to come out to equal 12. So then I would do algebra, I'd multiply both sides by 2 and get 9 plus x equals 24 minus 9, I would still get x equal to 15. But if you understand just kind of that, what you're doing when you're averaging something, you're getting the same distance from this point to this point and this point to this point. So 12 minus 9 was 3, so from 9 to 12 I added 3, so from 12 down I would have to add 3 again and get 15. Now for the y though, what was the definition of a midsegment? What do we know about point P in relationship to segment KL? Well, if you look up here, remember the midsegment has to be the segment that connects the two midpoints of the legs. So I could mark it like this is marked up here, that this is going to be congruent to this, and these two are going to be congruent. So then what's y going to equal? Y's got to be 3, because P has to be the midpoint if NP is the midsegment. Okay? Now, there's going to be a couple on your homework where setting up an equation is going to be a lot easier because they're going to have variables in it where you've got x's and such. So it won't be as quick as part A, although you will have some to practice like part A or like this one, part B, where you're figuring out, they give you the midsegment, you have to figure out one of the bases. But there will be some that have variables in them, and you can always check on Brightspace because I have the answer key to 8.5 bookwork. It's worked out, so you can kind of see what it was that I was doing for those problems. So those would be like your quote-unquote hardest problems, would be the ones where you're doing mid-segment stuff with variables other than just a single x in it like this. All right, and then leave about 6 to 8 spaces, however many you think you need to leave in order to answer your level 2 question that you're going to write for that trapezoid section. And then our last main idea is going to be kites, which is another special quadrilateral that we have. And so let's do a definition of a kite. A kite is a quadrilateral that has 2 pairs of consecutive congruent sides, but opposite sides are not congruent. So basically, I have one pair of consecutive sides that are congruent to each other, and then I have another pair of consecutive sides that are congruent to each other, but opposite sides can't be congruent. Okay, so that's why these are different lengths than these two. Because if I look across from them, they cannot be congruent, because if opposite sides are congruent, it is not a kite, it is a parallelogram. So a kite is a quadrilateral that has 2 pairs of consecutive congruent sides. So consecutive, they're touching each other. They could have also said adjacent, I guess. So these 2 sides, and then these other 2 sides are different lengths. Because opposite sides can't be congruent, otherwise it fails to be a kite, it would be a parallelogram instead. Now kites have a couple characteristics of their own. The first one, diagonals are perpendicular. Do I have a picture? Oh, I do, good. All right, so here's a kite because consecutive sides, 2 pairs of consecutive congruent sides. So if you draw in these diagonals here, they are going to be perpendicular to each other in a kite. Okay. And then exactly 1 pair of opposite angles are congruent. So when you have a kite, then the two angles where the different measured sides, I guess. So like where the single and the double meet, that makes an angle, and where the single and double meet, that makes an angle. Those are the angles that will be congruent to each other. Where the 2 singles meet and where the 2 doubles meet, that angle and that angle are not going to be congruent to each other. So the exactly 1 pair of opposite angles that are congruent to each other are these where the single and the double meet on each one. Where the 2 different side lengths meet each other, those angles opposite them are congruent. Okay? All right, so now paste in example 4, and you can go ahead and leave it on here if there's a couple of you that need to still copy this down or pause it or however you want to do that. and also paste example 4 in, and then after we do example 4, we're done. All right, so looking at this, find the indicated values. We're just going to find all of the angles. I guess I forgot to put on there which angles. They will in the book tell you what angle they want you to find, but let's find both of the missing angles in each one. Okay. So then on this one, you see it's a kite because you've got these consecutive sides congruent and these consecutive sides congruent. And so we don't have the diagonals drawn in, so we don't need to worry about perpendicular. But if we're finding angle measures, we do want to use the fact that we know that these two angles are congruent where the single and the double meet. So then when I look at this, where the single and the double meet is at M and K. So I know that these two angles are going to be congruent. So that's easy for finding one of my angles. So the measure of angle K is going to be 88 degrees. Okay. All right, and then what should the sum of any quadrilateral, if I added up the 4 angles in any 4-sided figure, how many degrees should that come out to be? 360. So if I added 88 plus 120 plus 88 and I subtracted that from 360, or you can do 360 minus all those angles. I'll write that out so you could see what I'm doing. Okay, so I know all 4 angles in any quadrilateral has to add up to 360, minus the 88, minus the other 88, and the minus the 120. So then the measure of angle J is going to be 64 degrees because that's what's left over. Okay, so that's your answer. Now again, you don't have to show all of this work. I was just showing you where I'm getting my numbers from. Okay. All right, part B is also a kite. You can tell by the markings, 2 pairs of consecutive congruent sides. And remember this, the angles that are going to be congruent to each other is where the single and the double meet on each side here. So the single and the double meets here. So that means angles M and angle K are going to be congruent to each other. Well, again, all 4 angles in a quadrilateral have to add up to 360 degrees. So I'm going to do 360 minus the 60 degrees and minus 50 degrees. So then that gives you 250 degrees. That's what these 2 angles should be, is 250 degrees between the 2 of them. And since we know they're congruent, then I need to cut that in half. So 250 divided by 2 is 125. So that means the measure of angle M is 125 degrees. And the measure of angle K is 125 degrees. So the last 3 problems, I think it is, or towards the end of your homework book problems, is using this information that we know about kites and which opposite angles are congruent, and then finding the angle or angles that are missing that they want. Okay? So your assignment is a book assignment, and it's listed on your orange sheet, pages 546 to 547. And that was numbers 3 through 15 odds. So you could check your answers in the back of the book if you don't check Brightspace. All of 18 through 20. And then 25 through 27. So again, the worked out solutions are on Brightspace, and if you can do these problems with no issues and you understand how to find each of them, then your 8.5 quiz tomorrow should be easy. Tomorrow we will do a review. I have a review assignment. In addition to this book assignment, I have a half sheet that the sub will pass out that says Chapter 8 review, and it's coordinate geometry review, because EOC is big on coordinate geometry, and you'll have at least 1 coordinate geometry problem on your test that you're going to take on Thursday. So it's a front and back half sheet, 4 problems to have you review how to do whatever it's asking you to do in the coordinate plane. Okay, so you'll do the book problems and then also see if you can do that half sheet, and then I'll take questions and such tomorrow, and then your 8.5 quiz looks like the book problems. Okay? get to work.